Today I want to talk about embedding AIMMS jobs into your application environment using the AIMMS Pro API. This is the flowshop model. You can launch AIMMS, create an AIMMS pack out of it. This is the demo page. You can do that yourself. It's a standard AIMMS example, so you can load it from the AIMMS examples. I've added some extra functions about it, which we'll see later on. You can create an AIMMS pack like this. Once you have created an AIMMS pack, you can publish it on a Pro server. I'm using this one as my own test server. Then publish an application right this way. Make sure you're using a recent version of AIMMS to the actual running, and publish it. Once it's published, you can start it by pressing the launch button, and you get more or less the same interface, except that you cannot modify it using the WinUI. That's basically it for Pro. By publishing this way, your users directly have access to the latest version of your application, and in this way you're very agile in working together with your users. So I'm going back to my presentation again. As you can see, you can support many models and you can support many clients, and AIMMS Pro provides you ways to configure it if you want to, who can run which models. That's AIMMS Pro in a nutshell. If you want to know more about AIMMS Pro, you can follow these links for the manual. There are also several webinars, and it takes too much time to recap all those webinars, but they're available on the internet for your for you. Now I'm getting to the AIMMS Pro architecture. As you've seen, I've walked through the portal, publishing an app. Oh, wait, hold on. Laser pointer. Here I've just gone through the portal, publishing an app, and again through the portal, launching an app. That's the way the normal interaction is. What we're going to do is slightly different. We're going to use another program that accesses directly the backend of AIMMS Pro and starting an optimization session so that we also have access to the solvers and run the application and giving back results to the application that started the job. If you want to know more about this architecture, you can find it on the internet following this link. I'm starting the Java demo now. This is the standard Java example that you can get via AIMMS Pro getting started. I've made the 3 changes to that example, namely the server that uses it and the credentials for the user that is running it. This program gets these credentials. So let's start it, and we start it by simply going to the debugger. The first thing I want to point out is that you are making a connection, a log on, so to say, and then you you log on, you create a connection, and you can already start using it. So let's see how we do that. So it boils down to creating a procedure call, which contains all computations to be done, potentially, of course, calling other procedures. The first thing we have to do is create a procedure call that is to be interpreted by AIMMS. The second thing we have to do is have a starting moment. What we do here is that we start it now with another minute. So there's a timeout of 1 hour. Well, we're not going to need that much time. Anyway, there's a timeout. We create a job and we start it. This is how you can see that. This is the same AIMMS Pro server. Here we have the jobs, and I just started this one. This is for one of my previous tests, and you can see it is created, but it's still waiting for the run to start. So can you please hold on for a second, or a minute rather, because we have a minute waiting time installed. I've tested this example using NetBeans 8.1. NetBeans 8.1 uses JEDEC and configured it using Java Development Kit 1.8. The AIMMS Pro API is written in Java 8 for your information. So let's see if the job already started. It's still on the created, sorry. I have to refresh the screen manually. Yeah, this is old, so I can delete it anyway. This is still waiting to get back to the previous. It should be coming on right now. Don't think I'm nervous. I am. Oh, it's already finished. So we should be getting back here as well, and we're now at the next item. So if you do not pass any additional information, this is a very easy way to schedule a particular job. I'm assuming the job can do all kinds of things. So let's continue with our work. We want to have some maintenance information about our current jobs. Based on our login, we can see which jobs we have currently access to. And so in this way, if you want to know which jobs we have access to, we can see that by creating a container for the jobs. Our server provides this container, and then for each job we can have access to all kinds of attributes, information about the job. I'm not going into much detail here. You can try to run it when you have the example yourself. It's rather easy. So, is that all we can do with a job? No, we can do more. Schedule a job and check the result. Let's see what this does. So here we have arguments. The procedure call can have arguments. When you create it, typically create some numeric and some simple string arguments. Although this is a way of providing the data to a job, it's not the preferred way. The preferred way is to using, for large amounts of data, the preferred way is to use a database, file IO, XML files, read from file, that kind of stuff, write to file. For a massive amount of work, but some configuration data, which you also typically fill in when you interactively work with your application. That's how you can do this procedure call. New here is the job interactor. So what is a job interactor? A job interactor is a point to which messages and events are returned from the AIMMS application. So whenever something happens to the running job, or it wants to communicate information back to its caller, that it can be handled by a job interactor. And now scheduled job, you can see it just not only has the job itself, but it also has the job interactor. And when we go into that, you see the role of the job interactor. It waits for some time, and then it goes and it creates an event for that. The event can be a timeout for the wait, or it can be an error, something weird happened to the job, or it can be a callback. I'll show how the callbacks work in a second, or we know it can be finished. Let's get out of here. So this is the interact loop schedule. We have here the procedure schedule job and a check result. Schedule job and check result. Here is what it does. Here you can have all kinds of computations, of course. Now it's rather simple, right into the listing file, which is not really interesting. But what is interesting is that you can call back using AIMMS. And when you go to the see how the callback is organized, it has input arguments, and the only thing it does is do a delegate to client, which is putting the input arguments back, wrapping the input arguments and sending a message back to the calling application. So from the AIMMS perspective, callbacks are relatively simple. And that's the interaction loop. You can also create multidimensional parameters and pass them back in. Let's see how. We create again a new parameter with dimension 2. That's this argument, and we create tuple value pairs, whereby the tuple has the same dimension as as the parameter we created, and the value is a numeric value. And each the values of on the indices of the tuple, we have strings. So now we create 4 tuple value pairs, and as you can see in your debugger, a tuple value consists of a tuple and a value. The name says it all. And we have here strings representing the values of the indices. The only way for the AIMMS Pro API is to work with these tuple value pairs if you want to provide indexed information. Again, for small amounts of information, this can be quite handy, but for large amounts of information, we suggest to use a database or file communication, as this is much faster. I'm going back to the interaction, and again I see that I can create a job configurator, and now I have advanced interaction, where once the number of timeouts is too much, I want to have I'm going to insert an extra call into the AIMMS job, and in this extra call this will be a priority call, so it will be executed first before the running job is actually finished, and it is intended for requesting small amounts of information or making an actual interrupt in the AIMMS model. I can also have a callback, so the AIMMS model can call me back and the name of the procedure can be obtained, and it's based on the name of the procedure. You should know what the arguments are, so you have to take care that these match carefully. You must be careful to match these with the arguments you check. And in this example you will see that it checks the amount of computation done, and it's a here output, here the logging output comes, and as you can see it waits for events on the job, and it checks whether things have been completed or not. This is more or less the end of the basic demo, or the Java demo, and I'm going to simply stop the job. And as you can hear, the job is finished because I stopped it, and I'm going to delete it because I don't really need it anymore. Oh, I also have other jobs created because of other parts I demonstrated just now. Okay, that's the first demo. Now I'm going back to the PowerPoint presentation. Let me first get back to what I'm actually showing, and that's the flowshop model. I'm not going into the mathematics of that, but it's quite an interesting kind of operations research application. We have a number of jobs to do, and for each job we have a number of actions to do. Or it has to be done on a machine, and they go through along those machines in a fixed order. What we also know is that the amount of time it requires per job per machine, except that this amount varies. You can imagine that painting job is not always the same. It depends on the type of object that you are painting. So per job the amount of time varies. And then you have to decide on the order of the job, and depending on the order of the jobs, the make span varies. You can see that here as follows in two solutions. In a Gantt chart I've seen, if you start with job 5 and then do job 1, 2, and so forth, you get a solution that takes 234 time periods, time slots, so to say. If on the other hand you start with a job 6, then 5, etc., then you get a solution which takes only 196 time slots. So it's really worthwhile to, for this instance at least, to check how much time it to check on the order of the jobs in order to find a well, to minimize the time needed to finish all jobs, the so-called make span. So I've written a C# program. I'm going to demonstrate that in a sec how that runs. But the C# program will solve things. Let's first show how it works and then continue here. Hold on. So I can set up the number of jobs I have, like here a lot of jobs, a lot of machines. So now I'm going to solve a really time-consuming job shop model. It's time-consuming because if you have 37 jobs, then for the first job you have a choice of 37. For the second job you have choice of 36, so you have n factorial number of possible schedules, which is a lot. And so how much, let's see what AIMMS does. I've just created the job and I'm waiting for half a minute now before AIMMS starts. My AIMMS Pro is configured to wait to check each minute whether there are jobs to be started, which, well, happens to be not too frequent now. Okay, you can see it is running. And it immediately found a first integer solution. So it has communicated back from the AIMMS app the intermediate solution, and it is still running. What you can also do is, well, for these long-running jobs, you can wait until all possibilities or until the solver proves it can no further improve the solution, or you can simply say, hey, I want to interrupt the solve. So now it should be get the status interrupted. It should get the status interrupted. I checked that in my previous runs. Or I can just kill it here, but I should get here interrupted. It's always nice when a demo fails when you're actually demonstrating. Okay, I was just too impatient. It says here cancelled, so this is the C# interpretation of what happens, and this is the AIMMS interpretation of what happened. So let's take a logical look via our PowerPoint spreadsheet of what happened. So what happened, what we've done. First, the C# program, I started by pressing the solve button, and this invoked a message to my AIMMS MIP application, the flowshop model, and it passed the arguments, and I've read in the data and AIMMS started to generate a mathematical program called the MIP solver, and the MIP solver starts finding integer solutions, so-called incumbents, because it tries to improve on the solution. Each time it finds a better solution, it will be called with an incumbent callback. That's an AIMMS procedure, and for the solve problem you can specify which AIMMS procedure to be called for doing the incumbent handling. The procedure I've written creates a message and sends a message back to the C# application, which subsequently updates the fields. As I didn't mention yet, the green lines are a procedure call encapsulated into a message and then passed to another program. It's the same here. a message is created and passed to another program. So after some time I press the cancel button, and this cancel button send a message, set cancellation message back to the AIMMS application. And this AIMMS application simply sets a binary parameter and waits upon the incumbent callback, or the waits upon a callback to be handled to handle this. Note that this is a safe operation, because conceptually at least AIMMS is a single-threaded program, thus you can either do procedures here or either do procedures there. AIMMS handles this quite easily. So instead of making a call, I just set a boolean, and this boolean is used and sees that program is to be cancelled. The callback actually terminates the solve, and it sends a message back to update the UI fields of the C# program, as you just saw. Because the solve is terminated, it provides the best solution back to AIMMS, and AIMMS is able to write down the optimal solution either in file or communicate it back to my C# application. So how does this look in code? I have to go back to another machine, because this machine has my Visual Studio environment. There is a lot of C# information here. Mainly I used the so-called background worker concept of C#, which makes it easier to do multi-threaded programming, whereby a user interface is to be maintained, and the C# program, which should be able to move it along the screen, minimize, maximize, that kind of events should be handled, and a long-running background job, whereby the long-running background job is handled in a separate thread. So I'll get back to this. As you can see, this is similar to the Java. I have connection information. Here I have credentials for logging in. I have specified the application name, and also similar to the Java application, this is how you create a connection. Then I created new parameters, which use the up-down controls of the Java for the C# application to specify the actual value. And I can do a procedure call which starts the actual generation of the mathematical program, and subsequently the solve of the mathematical program. Again, I want to use a job interactor in order to give me the callback information, and I start a loop waiting for events from the AIMMS application. Each second, because it waits for at most a second, each second it checks whether the cancel button is pressed, and if so, it will inject a procedure call. Let me recap here. The cancel button is pressed, and it sets the cancellation marker in my application. So there are several types of callbacks. So when a procedure call comes in, I have to check the name, whether it's a new incumbent information or it's the final result. And I've made myself a small procedure which supposedly rewrites the user interface of the C# with new information, refresh screen. And it's a bit of work with the background worker, but it says, well, report the progress you've seen so far. and you can see you can pass all as much information as you want using the background worker. And the progress change is the one that actually updates the screen, but it's on another thread. And I suggest you read multi-threading and background worker information from C# if you want to understand this in more detail. So that's how the C# application looks like, and it's not too difficult. Much of this comes with from you working with C# utilities. So this concludes the demo on C# and the Flowshop model. I will create an example out of this, both the solution and the Flowshop model, and put that on the example repository of AIMMS. Now I want to get back to my presentation. And come to the final important sheet. There are two ways in which you can embed AIMMS application into your application environment. A couple of years ago, AIMMS released the AIMMS SDK. And this AIMMS SDK has an API for C#, Java, and also C++ applications. And this interface does have a quick way of passing multidimensional data, as opposed to the Pro application, but they both are available for creating or embedding AIMMS application into your total AIMMS environment to hide it from the application being run. They both are able to do remote optimization, so that's similar up to that part. But for instance, a Pro application is also able to communicate with other Pro applications. It can be, it is able, well, you have all the advantages of AIMMS Pro basically. It's very easy published, and so that is also easy to share with your end users. You have user management, who is allowed to run which application. AIMMS Pro has web UI support, which is not really relevant to embedding, but still it's an important factor for AIMMS Pro. You can use the same application as a WinUI application, the Flowshop model you've just seen, and an embedded application. Well, that holds for a web UI as well. If you do have multiple runs in an embedded application, well, AIMMS Pro takes care of job queuing and management of the job. So when there are multiple, when you fire up multiple jobs, and each of these jobs wants to do a solve, AIMMS takes care via its licensing mechanism that not all jobs are run at the same time. The same holds for seats. When there are another basic advantage of AIMMS Pro is that cases are shared. Well, the embedded job can also use cases. If you have multiple licenses and multiple servers in your cluster, multiple solver licenses, then you can scale out using deploying your group of machines, which also brings me to the next point. If a machine needs maintenance and needs to be shut down for some reason, the other machines in the AIMMS Pro cluster take over, which makes it well, that the cluster is highly available, and the cluster will make sure that the jobs that are running on the machine being shut down are taken over by the other machines. But most importantly, I would like to stress that the AIMMS SDK is only bugs are fixed, and no longer new features are being added to it. Well, with Pro, there's a whole team adding continuously new features, which well makes it attractive for future developments as well. So for instance, we have on the roadmap cloud and Linux support. Before I'm going to allow you to ask various questions, I would like to point out that my colleague Haraldur Haraldsson will present next month the AIMMS Tableau link, which we will do that on January 20th next year.